Hello everyone, we'll try to see binary search using the recursive approach. So, what do you mean by binary search? Binary search is a searching technique which is going to find an element from your group of elements. So, to find this, it is going to follow some kind of a mechanism. So, it is always finding the middle position. By using that middle position, it is going to do the comparisons. So, whatever the value you are holding at the middle position, right? So whatever the value we are holding, first it will do the comparison whether it is equivalent to this. So we are going to say that your element is found. If the element, searching element, is smaller, then your element is going to be find it left side. If the element is going to be larger, it is going to find it right side. So this is the approach we are going to follow to find your element from the given array. So to implement this, first foremost thing is, first of all, your array has to be in the sequential order. Either it could be ascending, either it could be descending. So depends on your approach, right? So by using this sorting mechanism only, we can achieve that. So without doing a sorting of your elements, we couldn't able to apply binary search on your given group of elements, right? How this approach is going to be work? First, I am having set of elements like this 1, 2, 3 and 4, 5, 6, 7, 8, 9 and 10. So my index positions are going to be 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. So I'm having an array like this and my index positions are like this. So now what I am going to do, I am going to execute my logic from main method. So inside my main, I'm having a function called binary search. By using this function, I'm going to calling binary search function. By using this, I'm going to trace out that whether the element is identified or not. So if the element is not identified, I'm going to get the result as -1. If the element is found, I'm going to get the element representation. What exact position my element is going to be represented. Alright, so for this I'm doing a function call. So from your main, I'm going to execute some function called binary search. When I'm executing, automatically one more memory will be allocated for this, and here we are going to represent we are going to execute your binary search logic. What this binary search is holding, right? So we'll try to trace out that. So inside your binary search, there is a condition we had. First, we are going to check that for this comparison, at least we had minimum of 2 elements. So I'm going to compare that first instruction. If my array is consisting at least 2 elements, I'm going to do some kind of execution. If it is not consisting any kind of elements, I don't want to do the execution. So now first check high less than low. So my low value is this, high value is this. So obviously my high is greater than low value. So condition is true. My high is greater than low value. Condition is true. So now I am going to find the mid value. The mid value will be identified 0 plus 9. Low value plus high value by 2. So it is going to be 4.5. So index positions are going to be represented with the numeric representations. So it is obviously 4. So whatever the value you are having inside 4 will be treated as your mid value. By using this mid position, I am going to do the comparison with my searching element. For example, I am searching for an element 10. Right? How this approach is going to be done. Next, after this statement, I am going to search for the particular element by comparing with the mid value. A of mid is, our mid value is 4. So A of 4 is equal to M, 10. A of 4 value is what? 5. 5 equal to 10, condition false. Obviously what is going to be happen? Condition false. We are going for else part. So else part is consisting one more statement. If A of mid greater than 0. So 5 is greater than M value 10. Is the condition is true? So obviously it is false. So here you just observe, if this condition is false, I am going to execute else part. My else part is consisting by representation of return binary search a comma mid plus 1 comma I comma M. So now I'm going to do one more function call from this by representing your array values from A and mid plus 1. So my mid value is 4 and mid plus 1 is 5. Now after 5 I am having high value is 9 and my searching element is 10. So it means I am doing a new function call by using this variables. Now A value is array. The array is consisting all the elements, but it is starting with 5 ending with 9. I am going to compare only a few elements from the array. So what are the few elements? After when I am doing a recursive approach, so in this approach I am having an element 4 plus 1, the index position is 5, and 6 index position, 7 index position, 8 index position, 9th index position. Your values are 6, 7, 8, 9, 10. So I am going to apply my same functionality to get the answer, to find your element. So now again I am going to check my low value is less than or equals to high value. Condition is true. So I am going to find the mid value. 5 plus 9, that is 14. 14 by 2, 7. So 7 is going to be my mid index position. By using this mid index position I am going to retrieve the value 8. So 8 will be compared with your searching element. 8 equal to 10, condition false. I am going for next condition from your code snippet. So there A of mid is 8, 8 is greater than 10, his condition is true, obviously it is false. So I am going to look for else block. The else block is consisting of binary search, and from this again I am going to do one more function call by forwarding the values as A, and the next value is what? Mid plus 1, so that is nothing but 7 plus 1, 8. 8 to high value is 9, and next one is my searching element is 10. Now again I am applying a recursive approach. So here what is happening? So I am going to consist only two elements in this particular array, that is 9 comma 10. So I am having index position 8 and one more is 9. At least I am having two elements, so then I can apply my searching strategy, otherwise I couldn't be able to apply this. So now my low value is 8, high value is 9. So obviously low value is less than or equals to high, that is true. So 8 less than or equals to 9, sorry 8 less than 9, condition true. Now I'm going to find the mid position for this particular representation. So now 8 less than 9. So here low value 8 plus 9 is 17. 17 by 2, that is 16.5. Sorry, 17 by 2. That is going to be 8.5. So 8.5 indicates that the numeric value as 8. It will be floored to 8. So now 8 is going to be my mid position. So by using this mid position, I am going to search for the element. Is your 9 is equal to 10? Condition false. Next, 9 is less than 9 is greater than or equals to 10. The condition will be false. I am going for next representation. Now what is happening? I am going to search for the right side. So now again I am going to do one more function call. So here what you are consisting inside this function call means, so you are going to have your A value and here A value, and you are having high value as 9, mid plus 1, 9, and high value is also 9, and your searching element is 10. So now we are having only one element in this particular representation, that is right side element, that is 10. So now 10 is going to be identified. A of mid 9 equal to 10. 10 is equal to 10, condition true. We are going to say that yes, we found the results, otherwise we are unable to find the results. So here this is the way your binary search is going to be working out by doing some kind of recursive calls. Always your function calls are going to be generated. Finally, if you are not going to find the answer, for example, if you are not finding an answer, what will be happen? High greater than or equals to low. If it is not true, then automatically we will go for a return -1. So return -1 will be returning your value as a result. So next, back. Finally, we are going to have -1 value, and finally we are reaching result equal to -1. So then what will happen? It is true. So the element is not found in the array. So this is the output we are going to represent. So this is the way your binary search is going to be happen by using a recursive approach. So I hope you're having some kind of idea about binary search. So then I'll try to show you one kind of representation, actually what is happening and how this approach is working. Just try to understand this representation. For example, I'm having set of elements. I am only finding a middle value. After this, I'm searching for an element. Either it could be left side or it could be right side. So previously we were working with right side array. So again on this right side we are finding a middle value. Again we are looking for the element, whether it is finding fall to left side or it is fall to right side. So if it is fall to right side, so we are going to get this. So from these two elements we are going to find the middle position and we are comparing with the particular element, and again I am going to get a single value. For the single value also we are doing comparison. So it means what? For your searching an element from the given array, we are only considering off of the elements. So that is the advantage we have. And every time when you are comparing to find an element, I am doing one comparison, and after this we are going to consider only n/2 elements for the comparison. From the n/2 we are doing one middle value comparison, and after this we are going for the next recursive call that will consist n/2 by 2 plus 1, and next I am having n/2 by 2 by 2 plus 1. So every time my array is going to be divided by 2. Either it is going to be left side array or it is going to be right side array. So for this I am going to write a recursive equation 2t t of n, and every time whatever I am doing, so I am going to apply some kind of recursion on my n elements. So it is always going to divide either n/2 times plus 1. So only we are considering off of the element. If I am going to sort out, if I am going to solve this particular equation, I am going to get the time complexity as order of log n. Either it is coming to your linear search, we are going to get the time complexity as order of n. Your binary search is going to give order of log n. So this is the most advantage thing we had with the binary search instead of linear search. Linear search is going to search your elements element by element. Your binary search is going to search your element by considering only half of the elements from your array, either left array or right array. So we can do minimal comparison. So when you are going to find the result. For this, if I am having 10 elements from the previous example, I did only 1, 2, 3, 4 comparisons. Coming to linear search, to find the 10 elements, I need to do 10 comparisons to find the element. So with the minimal steps we can find the results, right? So I hope you are understanding. I'm done.